Hello friends, this video on P-block elements part 13 is brought to you by examfear.com. No more fear from exam. Let's go into another compound of boron, that is orthoboric acid. So the formula is BOH3 actually. So this is little white crystalline solid in soapy in touch. You can also write this as S3BO3. Both, if you see, both has 3 hydrogens, 3 oxygens and 1 boron. So both of the formula is valid formula. And they are sprawling, they are not that much soluble in cold water, but soluble in hot water, similar to borax. The structure, if you see, this is a boron and I have 3 OH molecules here. Here also, if you see, the boron has 6 electrons here. It is deficient of electron. Correct? And this is the shape, structure of this, and it generally forms this kind of cage-like structure where, if you see, it has formed this structure. There is a hydrogen bonding between oxygen and hydrogen here, similar to water also. If you see water, if you see H2O, right? Since water is oxygen is slightly electronegative and this is slightly electropositive. This is a slightly positive negative charge here in water, and they form hydrogen bond. Similarly, here also they form a hydrogen bond. Actually, if you see, that's why it is solid, right? Because the hydrogen bond, it forms this kind of structure, and that's why it is solid. So if you see any solid, just keep in mind, if you have any solid elements, it has to have some cage-like structure. Without cage-like structure, it won't be solid. For example, water is a liquid because it has some structure, but the bonding is not that strong. It is a little strong bonding here, so it has solid structure. If you see the diamond, it is more solid structure, so it is very hard. So if it is solid, it has to have some structure. Looking at this picture only, you can say that since it is solid, it has to have some structure, and the structure comes from hydrogen bond. The hydrogen bond helps this boric acid to get this kind of structure. So normally when you think of acid, you think of very strong acid with a liquid liquid state, but in this case, it is not the case. The boric acid is solid, and this acid is a Lewis acid actually. We'll talk about that. Let's discuss something more on the boric acid. It is a monobasic acid actually. We'll discuss more on this now. So the way to prepare this boric acid is nothing but you acidify the borax solution. So you have this borax Na2B407. This is something we know, right? You take this hydrochloric acid in water and make it aqueous, and then you react, you get this boric acid. Very easy to prepare. So from the borax, you can easily prepare boric acid by acidifying it in an aqueous solution. You can also form this by boron compounds. You have this halides, hydrides. From that also you can form the boric acid. And as I told, it is a layer structure with the hydrogen bond. If you see, this is my single BOS3 molecule, but it doesn't exist in this fashion. It is the cage-like structure with the hydrogen bond between oxygen and hydrogen, right? The next, as I told, that boric acid is weak monobasic acid. It looks like it has 3 hydrogen molecules, so it should give 3 hydrogen, but no, it is a monobasic acid because if you see, because it doesn't produce 3 hydrogen ions. It is not a protonic acid. It is a Lewis acid, right? It is all acid because the boron is electron hungry, correct? Correct. It doesn't donate proton. No proton donor. It is not a proton donor. The reason why it is acidic is because the boron is hungry of electrons, so it's an electron acceptor actually. Right. So normally acid, see the way you define acid generally is the one which can give H plus ions or the one which can take electrons. So normally most of the acid we think of as hydrochloric acid, sulfuric acid, they are strong acids and they are proton donors because they can donate H plus ions in the aqueous solution. But this guy, boric acid, is not capable of donating H plus ions in the aqueous solution, and that's why it is not a protonic acid. Most of the acid we think is protonic acid because they have capability of donating H plus protons ions in the aqueous solution. But this guy is not a protonic acid because it is a weak Lewis acid, and it is acid because it has it's electron hungry, correct? So, and if you see, the K is also very less for this. It's very weak. It's 10 to the power minus 9. So out of 10 to the power 9 molecules, only 1 molecule accepts the electrons. Very, very weak monobasic acid. correct? So the moment it reacts with water, water has an extra electron pair, it accepts that pair and it becomes this compound. Correct? It's not a, please understand, this is an acid. It's a very critical concept here. Boric acid is acid, but it's not a protonic acid. It is not having extra protons to donate, right? So it is not capable of giving protons. It is just that the boron there is electron hungry. It accepts the electron pair, so it is acid. And on heating this boric acid above 370 Kelvin, we forms the metaboric acid, HbO2. And when you heat it further, it gives boric oxide, B2O3. So you have this boric acid, you heat it, you get metaboric acid, you again further heat it, you get boric oxide. This is the property of the boric acid. You heat boric acid, you get metaboric acid and then boric oxide. Boric oxide, metaboric acid and then boric oxide. Let's talk about the uses of boric acid now. The first use is the enamels which we use in our home to paint the windows. That is used, boric acid is used there. It is also used to prepare heat resistant glass. It is also used to prepare antiseptics. It is used to prepare preservatives to preserve food. For example, the sauce, the canned food which we use, right? The juices, the canned juice, they use boric acid to preserve. And is also used as eye drop. Eye drop, the boric acid, if you see the word acid, the moment you think of word acid, you must think of word acridity, right? Acridity, it should be very hard, harsh. But boric acid, if you see, it's not a proton donor, it's a monobasic acid. So it is used in the eye. And that's the only acid which you can use in eye. Any other acid, if you use in eye, sulfuric acid, hydrochloric acid, your eye will burn. So don't try to use this any other acid in your eye. Boric acid is the only acid which is used in eye, because it is not a proton donor, it's not harsh. It is just, the name acid is given because Lewis acid and it accepts electron pair. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.